the quantity demanded is going to go down. Let me just erase this. So say we have a new price. And a new quantity. Oops. Go away. So we have a new price and a new quantity. And we have a new consumer surplus triangle that's now smaller. So this is the new consumer surplus triangle. It's smaller. It used to be this whole bigger shaded triangle. So consumer surplus is going down. And we can calculate the change in consumer surplus as this area here consisting of this triangle and this square. It's a parallelogram. No, what is it? Trapezoid. It's a trapezoid. So this trapezoid, we could give us a money measure of our change in consumer surplus. And that's what that's sort of fundamental to sort of economic analysis. We could say if the price went down, the quantity that we would consume would go up, and consumer surplus would go up. If we had a price down here, the triangle would be getting bigger. We would be adding, let's say we have a new price, price 2 that's a lower price, and a new quantity that's a higher quantity. We would have consumer surplus would go up, and we could calculate a change in consumer surplus of this lower price as that trapezoid there. So let's just think about this in terms of, right, here's just done in color, which is nicer. I wish I could get my pen to make those pretty boxes. That's the same thing that I just did. So we have our consumer surplus. It's an approximate measure of the change in welfare, but we will say it's a pretty good approximation. We can look through the demand curves that we have to try and make this intuitive. So this is the demand curve slide that we had before. So here we have implicit in this demand curve, we'll have some sort of triangle. And this is a consumer surplus. Oh, I think this is the donuts demand curve. Here, I'll spell it your way. Donuts. So we have a triangle of consumer surplus for donuts, sort of embedded in this demand curve. When we have a demand curve, we have an embedded way to see the consumer surplus. And then what we could do is that's the demand curve if price equals $1. And we could have a change that if the price goes from $1 to $2. So let me do that here. So this big triangle that I did was the consumer surplus if price was equal to $1. And then if the price went up to $2, we would have a smaller triangle here. And this, if we could figure out exactly what that size was, because we have the prices and we have the quantities, we could do a numerical measure of what the change in consumer surplus of changing the price of donuts from $2 to $1 was. We could talk to Michael Bloomberg in New York City about taxing trans fats. So we could have a measure for consumer surplus changing from $1 to $2. Here's another graph that we had Yosemite bus tours. So we have, this one is just, where I was trying to show that it could be chunky. And we'll have this price quantities schedule right here. That's price and quantities. So if the price at equilibrium was 55, and then we would know that the first 100 people, they thought that it was worth $95, but they only have to pay $55, right? So we have a measure of how much the consumer surplus of the first 100 people is. That's cool. Did that just make, I have no idea what just happened, but that was cool. All right, so we have a measure here. That's 1,000, that's 100 times 40. So for these people, we have $4,000 worth of consumer surplus for those first 100 people. For the second 100 people, look at that. I have no idea what, this is so cool. All right, so for the second 100 people, they were willing to pay $75 for their bus trip, but they only had to pay $55. And so that's 20, so there's $2,000 in consumer surplus for those people. So we have $6,000 in consumer surplus in this graph. So different ways that we're seeing demand curves. So here's that done through. Consumer surplus of $6,000. Now here is the graph from the textbook that I haven't talked through too much, but I hope you guys are reading through this example. It's interesting and it's motivating to the stuff we talk about later in the semester. It's talking about a demand curve for electricity. So they've been working through this demand curve for a while. And here they're talking about how we could shade these chunks out with increasing, this is that how wide are these things that we're going to then make an integral under a demand curve. But we can build these chunks out from different price points to build up a consumer surplus for electricity. So the total willingness to pay being an area under this electricity supply curve. So they're doing approximations and showing how this is an approximation. As you get smaller and smaller increments, it goes up higher and higher. Now, what I think is interesting, and I want you guys to pay attention to, is this discussion of what the price of electricity could be. And these two numbers are interesting, the $50 and $100. So what they talk about in the textbook is that if we're paying about wholesale price of about $50 now, but in some Scandinavian countries that want to stick to Kyoto commitments to reduce their greenhouse gas emissions to reach the targets under Kyoto, they're starting with a carbon tax. So other industrialized countries that are going to stick to carbon reductions by a carbon tax of roughly $50 a ton. So this is a simulation, in a way, of what it would be like to increase the price of electricity by $50. And so if we increase the price of electricity by $50, how much consumer surplus would be lost is this economic measure of how much would affect people. And importantly, a huge amount of revenue is getting gathered, right? So this is this question of if we have a carbon tax, is there a way to make an adjustment in a carbon tax to make it fair? So if the government is going to collect, and here, this bar here would end up being collected as government revenue. So for all this area, could the government transfer the benefits from the carbon tax back to people to offset the loss in consumer surplus? So could the government pay people back in some way for the carbon tax in a way that's neutral to citizens? So here we go. There's just, you can calculate this total surplus minus amount paid and get an exact money measure of what the surplus is. And then one more on the bus tours. We had a tax example in the bus tours, like our tax example in homework, where, so this is just one more demand curve. First, the consumer surplus is this triangle. Is this triangle. And then with a tax, we have a reduced quantity, a higher price, and now we are on this higher triangle. So we have a trapezoid. That's the change in consumer surplus. What's also interesting here is that we have this rectangle. That's the amount of revenue that the government is getting. A $20 tax times the quantity consumed. So we have a reduction in consumer surplus and an increase in government revenue. So we have this big triangle minus the smaller triangle gives us a change in consumer surplus that we can measure as a trapezoid. We have all the different numbers that we can read off the graph to calculate the size of that trapezoid. And this is back to that question on finally under the demand curve for electricity that I was drawing through. If we did a carbon tax on electricity, how much of a reduction would we have in consumer surplus, and how much transfer would we have? So to have this neutral to the consumers, this is the amount of money that we would need to offset consumers' income for their increased amount that they're paying in electricity prices. So I'm not going to get too much into this, but we have two measures that we do in environmental economics. We have equivalent variation and compensating variation that are two exact money measures going back to indifference curves. You can read through this in the book. So equivalent variation, the definition is if we have a price change, we will look to a change in income. So price changes are going to change the slope of the indifference curve of the budget constraint, and income is going to change the level up or down of the budget constraint. So equivalent variation is to a price change from P0 to P1 is the change in income that makes the consumer just as well off as if the price had changes. So if the prices had stayed the same, but income was taken away from the consumer instead of the price changing. So the consumer's up here at point A on a higher indifference curve and a higher budget constraint. The prices change to this new indifference curve that's steeper. I'm not going to be able to hit this right. So the prices change to this new point B. And the question for the exact money measure is if the prices had been the same, how much income would be taken away to put us at point C? Because we're on the same indifference curve between B and C. So that would be a change in income that reflected this change in prices. So the price went up, we went to a lower indifference curve. We're going to find a new budget constraint with the same price sets, but at a lower indifference curve. But they'll be tangent to the lower indifference curve with a change in income. So this has to do with how we ask questions in surveys. How much money would we need to take away from you in order to have the same effect as a change in prices? Compensating variation is slightly different. Is what would the change, we're going to have new sets of prices, we're going to have a steeper budget constraint. How much would we need to pay the consumer at the new prices to get them back to the original welfare level, to the original indifference curve? So in this one, we're starting at point A. Price changes, we're now on a steeper budget constraint curve. We're going to go to point B, and we're going to look at how much do we need to move their budget constraint up to get them up to point C, which is on the same indifference curve as point A. How much income would it take, like what sort of payment would it take to get them back to the indifference curve that they were on? Get them back to the same level of utility. Prices have changed, but we want to get them, because they only have so much money in their pocket, they're now affording less, we want to compensate them by a certain payment to get them back up to the higher indifference curve. That one's compensating variation. The price went up, we went down to a lower indifference curve. We're going to find a new budget constraint with a higher level of income to get them up to the original indifference curve. How much do we need to compensate the consumer? It's a different type of question that we're going to ask. The next few lectures, we're going to go through sort of the gristle of environmental economics, which will sort of be about, will relate to asking people surveys about how much environmental goods are worth to them. So we'll see some of this when we talk about the questions of surveying.